Hello guys, Mr. Milton here. Today we're talking about solving absolute value equations. After this lesson, you should be able to set up both equations to find the solutions to an absolute value equation. As a reminder, absolute value is a number's distance from zero. Okay, and when you think about distance, remember that distance can't be negative. If I run to the store, I run 2 miles. When I run back home, I run back home 2 miles. Okay, it's not 2 miles to the store, negative 2 miles back home. It's just 2 miles. So distance is always positive no matter the direction. Okay, same with numbers. Okay, and an absolute values equation is an equation that has a variable inside the absolute value bar. Okay, if there's just an absolute value somewhere and there's no variable inside of it, it's kind of not an absolute value equation at all. So here's an example of an absolute value equation. Absolute value of x equals 5. This is what you should say to yourself when you see these types of problems. The absolute value of what numbers are equal to 5, or which numbers are 5 units away from 0. And then I put the S in bold to emphasize that typically absolute value equations have two solutions. Typically. This is because there are two numbers that are 5 units away from 0. What numbers are 5 units away from 0? Well, 5, obviously, and negative 5, maybe less obvious at first. Okay, we have our number line 0, 5 units this way, 1, 2, 3, 4, 5, 5 units this way, negative 1, negative 2, negative 3, negative 4, negative 5. Okay. However, the number, or the expression inside the absolute value bars is usually more complicated than just x. So here's an example. We have the absolute value of 3x equals 18. We know that the two numbers we know that the two numbers that are 18 units away from 0 are 18 and negative 18. Therefore, we need to find out what values will get the expression inside the absolute value bars to equal those numbers. We need it to be 18 and negative 18. And to do that, we write two equations. The first equation is 3x equals 18. So basically we said, okay, it could be the positive 18. It could be the positive of this. But we also say, okay, 3x could equal negative 18. The negative of this. And then we solve each problem and find our solutions. And in this case, divide this by 3, we get x equals 6. Divide this by 3, we get x equals negative 6. Our solutions are x equals 6 and negative 6. Okay. Second example down here, we have the equation absolute value of x minus 4 equals 7. So we could say x minus 4 equals 7. Oops, I already have that here. And we could also say that x minus 4 equals negative 7. And so now for these problems, I'm going to add 4 to this side, add 4 to that side, x equals 11. I'm going to do the same thing here, x negative 4 equals negative 7, add 4 to both sides, and x could equal negative 3. So 11, negative 3. Alright, notice that this one has a number outside the absolute value bars. And before we write our two equations, we need to isolate the absolute value expression. It means we want just the absolute value bar there. In this case, we need to divide both sides by 2. we do not distribute the 2. Do not distribute the 2. And so when we divide both sides by 2, we will have divide by 2, divide by 2. The absolute value of x plus 7 equals 9. Now that the absolute value expression is isolated, it means no numbers outside the bars, we can write our 2 equations. Our first one, x plus 7, the numbers inside could be 9, or the numbers inside could be the opposite of 9, negative 9. And then we solve both of those problems. Subtract 7 from both sides here, we get x equals 2. Subtract 7 from both sides here, negative 9 minus 7 is negative 16. Okay? If you feel like you got this, go ahead and try it. If not, you can follow along with me until you feel comfortable, and then I would encourage you to try it. Alright, so let's add a little bit more to that. We got more stuff outside of here. We're going to treat this absolute value like the variable. We want to get everything away from that. So we're going to follow the same process to do that. I'm going to subtract 1 from both sides. So I get 4 times the absolute value of 2x minus 5 equals 12. I'll divide both sides by 4, so I have the absolute value of 2x minus 5 equals 3. Alright, and now I have my absolute value by itself. So now I'm going to write my 2 equations. 2x minus 5 could be 3, or 2x minus 5 could be negative 3. I'm going to solve both of those equations. 2x could equal 8, add 5 to both sides, and x could equal 4. It's one of them. Then I'll do the same thing to this side. I'm going to add 5 to both sides. So 2x equals 2, negative 3 plus 5. Divide by 2, x will equal 1. Alright, do the same thing for number 2. 10 minus 3 times 1 minus times the absolute value of 1 minus x equals 4. So I'm going to subtract 10 first. So I have negative 3 absolute value of 1 minus x equals negative 6. 4 minus 10. Then I'm going to divide by negative 3. Okay, so I have the absolute value of 1 minus x equals positive, oops, not 18, that's multiplying. Write my steps so I don't do that again. Positive 2. So now I can write my 2 equations. 1 minus x equals 2, or 1 minus x will equal negative 2. Or and, I guess I should say. Alright, and so now I'm solving this. I'll subtract both sides, or 1 from both sides, so I have negative x equals 1. To get x by itself, I need to divide or multiply by negative 1. Be the same outcome, so I really don't care which one you do. I will subtract 1 from both sides here. I have negative x equals negative 3. Multiply by negative 1. Show you that it comes out the same way. So x could be negative 1 and 3. Those are our 2 options. Alright? Alright, so special case, when you isolate the absolute value here, and try to get this by itself, so we subtract 13 from both sides, gives us negative 8. We divide by 2, it gives us negative 4. It tells us the absolute value of x plus 8 equals negative 4. Many people will just automatically move on to making 2 equations, but think back to what I had to say at the beginning. Which numbers are blank units away from 0? In this case, which numbers are negative 4 units away from 0? If you think about this, this situation is impossible. Remember, if I run 4 miles to the store and I don't run negative 4 miles back, I run 4 miles back. There's no negative distance. Therefore, this equation has no solutions. Before you say no solutions, though, you must isolate the absolute value expression first. you cannot say no solution just because there's a negative number. So look at this situation. There is a negative number here. There's -1, but that doesn't mean, nope, we can't do it. Okay, that's kind of a shortcut cheater's way out. Okay, don't be lazy. You got to go through and do the whole thing. So I'm going to, before I say no solution, I'm going to make sure I have my absolute value by itself. Subtract 6 from both sides, and that will give me negative absolute value of 3 plus n equals -7. Okay, and now my absolute value is still not by itself. It's still not by itself, so I need to get this by itself, and again I'm going to multiply or divide by -1. Doesn't matter which one you choose. I'm going to move that up here. When I do that, I get the absolute value of 3 plus n equals +7. And so now we see we can do this because the absolute value is positive and it comes out to be a positive number. So now I could say 3 plus n equals 7, or 3 plus n could be -7. And now I'm just going to solve for n. Subtract 3 from both sides here. N could be 4, 7 minus 3. Subtract 3 from both sides here. N could be -10. So n equals 4 and -10. Okay, so thinking a little bit differently with absolute values, hopefully at the end of this video now, you should be able to solve absolute value equations with variables inside the absolute value brackets and outside of the absolute value brackets. Alright, see you tomorrow for some more practice.